Hey everyone, if you all are here, then start making some noise in the chat box, everybody. If you can hear my sound in the background, everyone, start making some noise because we are about to begin. Hello everyone, welcome back to Vedantu's physics channel. I hope that everybody is doing good. सभी लोग एकदम मजे में हैं. Okay, things are going great for all of you guys. Yes, that's what we always have to believe in ourselves for, right? तो बच्चों थोड़ा सा डिले हुआ स्टार्ट करने के अंदर, बट डू नॉट वरी. डिले स्टार्ट किया है पर हम लोग बिल्कुल उसी स्पीड से चलेंगे जिससे हमें जाना चाहिए. और डेफिनेटली हमें चैप्टर नंबर 1 की एक्सरसाइज जो है उसे कंप्लीट करना है आज, एंड दैट इज एनसीईआरटी सॉल्यूशन फॉर इलेक्ट्रिक चार्जेस एंड फील्ड्स. कल क्वेश्चन नंबर 17 तक सॉल्व कर लिए थे हम लोगों ने, और आज क्वेश्चन नंबर 18 से क्वेश्चन नंबर 34 तक हम लोग जाने वाले हैं, एंड दैट्स व्हाट वी आर अबाउट टू डू गाइस. Okay everyone, now see that I'm still speaking in Hindi plus English. Reason being, I conducted a poll on this channel and I'm still awaiting more students to respond, because as of now that is a very 50-50 kind of response that I've received, so I'm confused what to do. If eventually that goes the case, then I'll have to keep it Hindi plus English only, but let's see. If there are more people who are interested in me to continue the channel in pure English, then you'll have to bring more people to like that or vote for that particular that poll. Okay, fine, superb. So everyone, without any further delay, we have already been delayed by half an hour, so let's continue and start the session. This is for all those who are in 12th standard and preparing with CBSE or preparing for CBSE board examination. So all those who are new on the channel, guys, this is me or Suri sir. I'm a BTech from IIT Bombay, and many students call me Mogambo on YouTube, because when you crack any examination that you prepare with me for, Mogambo खुश होगा. Okay, if you want to follow me on Instagram or want to message me on Telegram, provided you here, I'm trying to get more active on both of them. Okay, let's see how it works out for all of us. And yes, you might think that we are late, but let me tell you that we are late, but we are latest, and that's why we are going to do amazing things to establish ourselves better. We will not leave any stone unturned. So we have started with this board series. One more poll I have conducted on the channel, and that poll was about whether you want me to do things which are related to NEET, and 3 options related to NEET, and one that I am only here for boards preparation, so I am here for boards. So that option got a lot of votes, so we are continuing with the board series. Next week I'm going to begin something for NEET as well, so stay tuned. I might drop a surprise session tomorrow itself, that is Sunday. Okay, yep. So everyone, let's begin without any further delay. Let's start. Let's pick up pen and notebook at your end and solve करना शुरू करेंगे everyone. Fine, so question number 18 onward शुरू करते हैं without any further delay. Question is right in front of you guys. Okay, will not take a lot of time in numerical problems. Most of them are numerical, few of them are proofs, so we'll do that. Okay everyone, so you see that a point charge 10 microcoulomb is at a distance 5 centimeter directly above the center of a square. So it is at 5 centimeter as shown in the figure. So what is the magnitude of the electric flux through the square? Hint has also been given in NCERT that think of the square face as one of the cube with the edge 10 centimeter. That means if you draw a cube here whose side length is 10 centimeters. Okay. This way, okay, not drawn like up to perfect proportion, but this is how it is. And what you see guys, यहाँ पे Q charge है everyone, and that charge is given to us as 10 microcoulomb. Or because of this charge, can I say that flux will come out from all possible 6 surfaces, right? One will go there and one will come here also. So can I say that this shaded portion that you see, alright, what just happened? Hold on. Just a moment. Yes, now by that एक चीज़ याद आ गई मुझे. I remember one thing. In the description box, you will find the link for all the session PDFs. The last session PDF is also updated, and I've shared a folder link where you will find all the session PDFs there itself. Okay, everyone, superb. So moving on, we are talking about this surface, and in that surface, can I say that for the entire cube which we consider as a Gaussian surface, the total flux has to be equal to Q by epsilon naught. So for 1/6, can I say that the flux is going to be Q by 6 epsilon naught, right everyone? Q by 6 epsilon naught is going to be the flux, and question is asking us what is the magnitude of this flux through this square. वही calculate करना है हमें. So Q value is 10 into 10 to the power minus 6, and this is 6. And let me do one thing, guys. Let's multiply this by 4 pi and divide this by 4 pi. So this becomes 4 pi Q by 4 pi epsilon naught into 6. 4 pi epsilon naught is basically the Coulomb's constant. That's what it reduces itself to. So now you see it becomes easier to solve it because K का value अब हमें पता है. So 4 into 3.14 by 6, and let's do one more thing. This is 2, this is 3, cancelling out that also, and this is 9 into 10 to the power 9, and the charge value is 10 to the power minus 5. Straight away I'm writing that for you all to understand faster. So you have 6 into 3.14 into 10 to the power 4, and close to 18 point something into 10 to the power 4, or we can say 1.8 into 10 to the power 5 Newton meter square per Coulomb. Okay, everything, let me write it in same color. Everyone understands why we have divided it by 6. Okay, cool. Janta, if you are here, start making some noise in the chat box as well. Okay, so answer is this. Achha, let me tell you one correction in NCERT. Question number 1.18 यानी कि 18 क्वेश्चन, 18th क्वेश्चन जो है उसका आंसर दिया हुआ है 2.2 into 10 to the power 5, एंड क्वेश्चन नंबर 19 नेक्स्ट क्वेश्चन का आंसर दिया हुआ है 1.8 into 10 to the power 5. द आंसर्स आर जस्ट जम्बल्ड. ओके, क्वेश्चन नंबर 18 का आंसर जो है that is given as 2.2, but actually the answer is 1.8 into 10 to the power 5. Okay, and next question, when we are going to that now, you'll find that the answer for that is given as 1.8 into 10 to the power 5, which is not the case there. Okay, so let's begin. A point charge, next question, of 2 microcoulomb is at the center of a cubic Gaussian surface, 9 centimeters on the edge. What is the electric flux through the surface? Doesn't matter how big the Gaussian surface is, flux is always going to be Q by epsilon naught. Doesn't depend on the shape and the size. We already know that. Okay, Janta. So the charge value is 2 into 10 to the power minus 6 and 8.85 into 10 to the power minus 12. So when you simplify this value, guys, this will come out to be 2.2 into 10 to the power 5 Newton meter square per Coulomb. If you want, you can actually simplify the approach itself, that the flux is Q by epsilon naught. You can multiply by 4 pi, divide by 4 pi, so that it looks like 4 pi kq. So you can write this also. This is an alternate, okay, alternate approach to begin the question. Then only multiplication is needed, and charge value is 2 into 10 to the power minus 6. So simply have to multiply this. So you have like 8, 9, 72, 72 into 321 point something will come out to be 10 to the power 10 to the power 4 it will be. So it will become 2.1 into 10 to the power 5. That way also. Okay. Sir, will you do only NCERT or PYQs also? By PYQs, do you mean PYQs of boards or PYQs of competition? RD. As of now in this series, we are doing only NCERT. In this session, only NCERT. Okay, I hope it is clear. RD, we are only doing NCERT in these sessions. Maybe later on, some new series if I'll come up with, we'll do something which is related to PYQs of NEET also. Okay, now next question says a point charge causes an electric flux of minus 10 to the power 3 Newton meter square per coulomb to pass through a spherical Gaussian surface of 10 centimeter radius centered at the charge. So charge is at the center of a spherical Gaussian surface. From there, that much flux is coming out. Question says that if the radius of the Gaussian surface is doubled, then how much flux would come out of it? Nothing changes. So if this is your Gaussian surface of radius r, even if you make the radius double, the flux remains q by epsilon naught, because it does not depend upon the shape or the size. So what is the value of this point charge has also been asked. So we can say that q will be equal to epsilon naught multiplied by flux. So 8.85 into 10 to the power minus 12 into 10 to the power or minus 10 to the power 3. So 8.8 with a minus sign nanocoulomb. So 8.8 nanocoulomb magnitude wise. Okay, of course RD, of course, that's what I said in the beginning. शुरू में मैंने बोला भी that we will be starting off with NEET series, another series parallelly to this one on the channel Monday onwards. Okay, either I'll tell you Monday we will be launching the series and we'll start with things which are in sync with the preparation of NEET. That will be dedicated only for NEET. Okay, everyone, superb. So this one is also done. Let's go to the next question. In this question, a conducting sphere of radius 10 centimeter has an unknown charge. If an electric field 20 centimeter from the center of the sphere is this much and it points radially inward, then what is the net charge on the sphere? So first of all, it has to be a negative charge because it is pointing inward, and we know that electric field is given by kq by r square. So we want to find out the value of the charge on the sphere. So that is going to be ER square by K. So electric field is 3 by 2 into 10 to the power 3. The radius of that position of that thing is 20 centimeters. That means 2 into 10 to the power minus 1. Squaring that will give me 4 into 10 to the power minus 2. And this whole thing is divided by 9 into 10 to the power 9. So this cancels it 3 times. This cancels it 2 times. We have 2 by 3 into 10 to the power 9 goes upper, becomes negative. This is 10 to the power 1 or 10. This is 10 to the power minus 10. So this becomes 10 to the power minus 8 or 0.667 into 10 to the power minus 8. So the value is 6.67 nanocoulomb. 6.67 into 10 to the power minus 9 it becomes. Right, everyone? Have a look. Next one. A uniformly charged conducting sphere of 2.4 meters diameter has a surface charge density of this much. Find the charge on the sphere and what is the total flux also. So again, conducting sphere, diameter given, and question is asking us only the charge value. So we know that the charge density is given by Q by area. So Q has to be equal to sigma into area, that is sigma into 4 pi r square, because that's a spherical body we are talking about. So we have sigma as 80 into 10 to the power minus 6 into 4 into 3.14 into r square. So that is 1.2 meters radius. So squaring that 1.2 will make it 1.44. Multiply these whole thing, you will get the value as 1.45 into 10 to the power minus 3 coulomb. So you can do the multiplication very easily. and find out the value also. Okay, Janta? Going to the second part where they're asking the total flux. So of course the total flux is nothing but Q by epsilon naught. So the charge that we have got is 1.45 into 10 to the power minus 3. Divide this value by 8.85 into 10 to the power minus 12. That's the value of epsilon. You want, you can multiply by 4 pi, divide by 4 pi and then solve. That also will give you the answer as 1.6 into 10 to the power 8 Newton meter square plus Newton meter square per coulomb. Okay, everybody, so that's how we are approaching. Next one, this one is an infinite line charge. It produces a field of this much at a distance 2 centimeter. Calculate the linear charge density. Later on in the same exercise they have asked to derive the formula also. Okay, and let me tell you, in NCERT the answer is given incorrectly. So this is the correct answer. So if you have gone through the exercise, then you will find out that the answer is given as 10 nanocoulomb or something like that has been given. So this is not the correct. They have given 10 microcoulomb as the answer, which is not possible. 0.1 microcoulomb is the answer. Okay. So please do only questions in this channel, sir. Please, because your videos were there already and we can know how to approach the problems to solve. Don't worry, Hardy. I will come up with a plan and I will get back to you. Expect a video either by tomorrow or max by Monday for NEET planning, and we will try to help you guys out more with problem solving. Okay, we'll do as many as we can. Okay, cool. So this one, let's do this first. An infinite line charge produces a field of 9 into 10 to the power 4 at a distance of 2 centimeter. Calculate the linear charge density. So first of all, electric field due to an infinitely long thing is given by 2k lambda by r. They're asking you to find out lambda, which will be E into r by 2k. So electric field is 9 into 10 to the power 4. Multiply this value with the r, that is 2 centimeter, or 2 into 10 to the power minus 2. Divide this by 2 and you see this 9 into 10 to the power 9. Now see, this 2 cancels with 2, 9 cancels with 9. This you have is 10 to the power 2 by 10 to the power 9. That means बहुत आराम से आंसर आता है that lambda comes as 10 to the power minus 7. Okay, so please corrections accept karo for your NCERT as well. Okay, and if there is a way you can communicate with NCERT, CBSE, do tell them that Suri sir ने बताया आंसर गलत है वहाँ पे. Okay, next one. The two charged thin plates are parallel and close to each other, and on their inner faces the plates have surface charges which are of opposite signs. So question is asking us, if the magnitude of this much density is given sigma, then what is the electric field between the two plates, left side of the plates, right side of the plates? First of all, everyone, if this is a plate which has plus sigma charge density, then you know that at a point somewhere here, let's call that point to be B, because I'll consider one point here as A. The electric field due to this is given by sigma by 2 epsilon naught, and this side also sigma by 2 epsilon naught. That's the direction when the charge density is positive. Okay, now if you have another plate negative charged, so for that plate the charge density will be towards the charge. So if I consider a charge point C here, so density will be this side, that is sigma by epsilon naught, sorry 2 epsilon naught. At this point it will be towards the plate, that is sigma by 2 epsilon naught, and because of this plate the electric field at this point will be sigma by 2 epsilon naught. I hope कि color code से सबको समझ में आ जाएगा कि हम कौन सी plate की बात कर रहे हैं. Everybody understands which color code is representing which plate, and likewise this will be also sigma by 2 epsilon naught. Okay. So what you see here, everyone, these two are cancelling out, giving you EA as 0, and these two also cancel out to give you EC 0, answer to option A and option or question A and question B, and electric field at B will be sigma by epsilon naught. Okay, easy peasy. Very well. So that's what 1.24 is. Let's go to 1.25. This says that you have an oil drop of 12 excess electrons and it is held stationary under a constant electric field of this much magnitude, like that Millikan's oil drop experiment where the oil drop is suspended with electric field trying to apply a force upward on that drop, and electric field applying a force upward while gravity is applying the force downward, and the drop balances somewhere in mid-air. So the density of the oil is given, estimate the radius of the drop. That's what the question is asking us to do. Assuming that it's a spherical drop, you have a QE force acting upward and you have a mg force acting downward, and we want to find out the value of radius. Okay, so when we say mg must be balancing QE, we will say that mass of anything is 4 by 3 pi r cube into g, and this is n number of electrons, which are 12. So we can say that the radius is going to be NE capital E into 3 by 4 pi g. 4 pi g comes here. Okay, and density also 4 pi r cube into rho into g. That's your weight, and this goes in cube root. So 3 into 12 number of electrons, every electron has a charge of 1.6 into 10 to the power minus 19. Remember, these type of lengthy calculations you are not expected to do yourself. At times you can use the log table in the board examinations. JEE and NEET do not anyway bother you with this level of calculations. They don't even want you to take the G value as 9.81. So they do not check your calculation skills, but boards do. Okay, so 4 into 3.14, G value is 9.81, and density is given in gram per centimeter cube. So 1.26 into 10 to the power 3 kg per meter cube. Okay, Chinta? This thing, whole cube root. So when you simplify this, that's the answer that you should get. 9.8 into 10 to the power minus 7 meters, or 9.8 into 10 to the power minus 4 millimeters. Have a look, everyone. I hope everybody is comfortable so far. Okay. Fine. Let's go to this one. Now this says that which among the curves shown here is not possibly representing an electrostatic field. So see guys, first one is a conductor from where you can see that electric fields are not always coming out at 90 degree. Like this angle is not 90 degree, this angle is definitely not 90 degree, this one is not 90 degree, oh, this one is not 90 degree. So there are so many which are not. So because your electric field lines from a conductor come out at 90 degree, because electric field from a conductor which we assume that it behaves like a equipotential surface. We don't assume that it does. It does behave like an equipotential surface because it's a conductor, so it has to have the same potential at all the points, then only the charges reside on the surface. So the electric field lines always come perpendicular to a equipotential surface. Now this one you say that from positive electric field lines going away, from positive electric lines going away, but from negative also field lines are going away, not possible. Okay, for positive the electric lines cannot terminate there. But this one looks about right, because field lines are going away from the positive charge, they are repelling each other. So far the third one is the correct representation of electric field. Now this one, if we talk about, they are intersecting with each other, they do not intersect with each other, okay, the field lines, and you see that the loops are being formed. Electric field lines don't form the loop, so these two are also not the correct representation of electric field. Okay everyone, let's go to the next question, 1.27. So in a certain region of space, electric field is along the z direction throughout, and the magnitude of electric field is however not constant, and it is increasing along the positive z direction. So let's consider this to be your electric field, such that your electric field is increasing along z direction at a rate of 10 to the power 5 Newton per coulomb per meter. Okay. Also, it has been given to us that there is a dipole that you are placing. एक dipole रख रहे हो यहाँ पे, which is pointing from towards the negative z direction at the rate this one. And what is the force experienced by a dipole, which is 10 to the power minus 7 in the negative z direction? So you see that here this positive charge will experience a force in the direction of electric field, while this negative charge will experience the force in a direction which is opposite to the electric field. And if I consider this here, E1 is weaker than E2 as the electric field is increasing as you are going here. So definitely F2 is greater than F1. So we can say that F net is not 0, it is rather F2 minus F1, and that F2 minus F1 force is basically Q into delta E. Okay, I can write Q into delta Z into delta E by delta Z, and this Q into delta Z is the dipole moment, and this is delta E by delta Z given to us. So this value is 10 to the power minus 7. Okay, direction is already known, by the way. This is going to be, the net force is going to be towards the negative Z direction, and this is given to you as 10 to the power 5. So we have 10 to the power minus 2 minus k cap. Okay, Chinta? How about the torque? As the force is parallel to the electric field, or if we talk about the torque also, which is P into dE into sine of 0 degree, that's going to be 0, because the angle between electric dipole and this is not 0, 180 degree, rather unstable equilibrium hai. So that's the answer. Okay everyone, now this one, it's more of a conceptual question. It says that a conductor is shown with a cavity and it has been given a positive charge Q. We have to show that the entire charge must appear on the outer surface of the conductor. So guys, have a look at this. If I consider a Gaussian surface here, you know that for a conductor the charge always resides only on the outer surface. So when you do this, you will find out that the Gaussian surface flux will come out to be 0, okay, which is Q in by epsilon naught. This also proves that the net charge placed inside is 0, the first part. Okay, in the second part it says that if I place another charge small q here, then prove that all the charge will come on the surface only. So assuming that there was no charge which was there in the cavity, and now the charge which was there was only on the surface, that was capital Q. So now when you are giving a plus q charge here, what will happen? A negative charge will get induced here. Okay, such that when you draw a Gaussian surface, the net flux inside the metal or conductor will remain 0. So this is minus q charge which comes here. And because of the charge conservation law, the same amount of positive charge has to also appear on the surface. Are you guys getting this part? That in a conductor, the net electric field always inside is 0. And that is what it tries to do. The electric field inside has to be 0 in the metal body. I'm talking about this region. The electric field has to be 0. Then only this happens. Here also the electric field has to be 0. So no flux should come out of the cavity, is what we are saying. Okay. Now third one says that a sensitive instrument is to be shielded from the strong electrostatic field in its environment. Suggest a possible way. A sensitive instrument like your mobile phone, if you put it in a aluminium foil and then you try to call your phone on your phone, you will see that the phone will never get connected. Why is that so? Because when you put something in a metallic body, then the field lines are restricted to go inside, and because of that, the electromagnetic radiations which contain electric field, they do not even penetrate and go inside the foil, and you will not receive any call. And that's what happens inside most of the lifts also. Elevators which have metal bodies, if they are completely shielded, when you're talking on phone inside the lift, you will either not get any call or you will not receive any signal altogether. That's why we can say that if you put anything inside a metal body, it will remain shielded. So a closed metallic body acts as a electrostatic shield. Okay. Next one, Janta. Now this one says that a hollow charge conductor has a tiny hole cut into its surface. Show that the electric field in the hole is sigma by 2 epsilon naught n cap, where n cap is the unit vector in the outward normal direction and sigma is the surface charge density near the hole. First of all, near any conducting body, the overall electric field, we know this from Gauss's law, is given by sigma by epsilon naught near the surface. Okay. Now imagine if I create a cavity here. Okay, then what happens in the, if I create a cavity here, then it means some amount of this electric field will get affected, right? So when the cavity was filled, this electric field does not get affected. Also, when the entire body was present, inside any point, the electric field inside is 0. So just imagine inside this point or this surface, the electric field is 0. Outside, it is sigma by epsilon naught. That means what? The amount of electric field which is created by this portion with the cavity at say this point now, at an interior point here. Okay, let's consider this was the case earlier. Okay, now to keep this value 0, you will require 2 electric fields, right? So just imagine you have this positive charge density. So this entire positive charge is trying to create an electric field here, which is say E1. So if I fill this cavity back, if you remove this cavity, then the electric field has become non-zero because it is no more an entire full conductor. So when you fill this cavity back with that positive charge, the electric field should cancel out E2. Okay, and that simply tells us that E1 has to be equal to E2 in order to cancel out. And right outside also, the electric field on filling this E out, okay, so E in is 0, that's why E1 is equal to E2, and E out is sigma by epsilon naught. So can I say that if sigma E1 plus E2 is resulting this electric field, because if this cavity is also positively charged, okay, if this cavity is also positively charged, then the cavity is creating an electric field E2 here, and you have E1 already in that direction. So both of them added, that means 2 times of, we want to find out because of the hole. So hole, the electric field is coming out to be on the right hand side, that is n cap. N cap is the unit vector, outward normal. So we are finding E1. That comes out to be sigma by epsilon naught. Overall value is sigma by 2 epsilon naught n cap, that is outward normal. Make sense, everyone? What we are saying, right outside the conductor electric field is sigma by epsilon naught, and right inside it is 0. So if I remove a portion, that means I am imbalancing it. So, and inside, if I still want the electric field to be 0, I have to refill the cavity. When you refill the cavity, it makes it 0. That means E1 and E2 are the two electric fields which are equal. Then only the electric field is 0. Outside, the electric field is sigma by epsilon naught. That means both of them are sigma by 2 epsilon naught. So that is why sigma by 2 epsilon naught, and that too normally outward direction. Okay. Now comes the derivation, which you all were waiting for maybe. So you have to obtain the formula for electric field due to the long thin wire of uniform charge density lambda. Okay, and you do not have to use the Gauss's law without using the Gauss's law. So assuming that you have a infinitely long charged conductor having charge density lambda, and this is its, say, reference point. From there at a distance x, I'm considering a dq charge. Okay, that dq charge has a width of dx. So if I consider a point somewhere here, P, okay, so this dx charge is subtending an angle d theta here. This angle is theta. So this is a constant distance r. This is x distance from the reference point O, and this is a variable distance, that is small d, whose value will be under root of r square plus x square. This is r square plus x square, the hypotenuse. So at this angle theta, the electric field due to this dq charge is dE, which has theta angle with horizontal. So it has dE cos theta x component and dE sin theta y component. We want to find out the net electric field. So first of all, everybody, if we want to write down dE, it is going to be k dq by d square. This is the distance d square. Okay, I can write down dq as lambda dx, d square as r square plus x square. Okay, Janta. Now you see that here in, say, this right angle triangle, if I write down tan theta, that is x by r, that means x is r tan theta, and I will require dx, that will be r sec square theta d theta. Why am I doing that? Is because when this element goes to the other infinity, the angle will become minus pi by 2, and when the element goes to the upper infinity point, then it will become plus pi by 2. So my limits for angle are easier. So I'm going to replace dx and everything in terms of x. Okay, so x will become r tan theta. Let me write that also. So I have k lambda, I have r, which is the constant. So this is dx, which is equal to r sec square theta d theta, and this r square plus x square is r square plus r square tan square theta, which means r square taken common, 1 plus tan square theta, and that is sec square theta. So we are going to replace the denominator as r square sec square theta. So you can very well see sec square theta getting cancelled, one r gets cancelled, and what you are left with here is k lambda by r d theta as the electric field vector or its magnitude. Breakthrough, because now you have your electric field overall that you want to find out. You will say that your electric field is integration of dex I cap and integration of dey j cap. Okay, hope this is making sense for all of you. we have found DE. So now we know that DEX is DE cos theta and that is DE sin theta. So let's go to next and find this out. The overall electric field is DE cos theta I cap and DE sin theta j cap. This goes from minus pi by 2 to plus pi by 2 in both the cases. So everybody, this is 2k, this is k lambda by r integration of cos theta d theta I cap from minus pi by 2 to plus pi by 2. Okay, then you have k lambda by r integration of sin theta d theta j cap minus pi by 2 to plus pi by 2. Okay, so cos theta ka integration we all know and we can put the value also. Cos theta ka integration is sin theta, not minus sin theta. Okay, and you can put the limit minus pi by 2 to plus pi by 2, and same way mein this is minus cos theta, limits put up, so when you do this, this will give you 0 and this will give you 2. So your answer will be 2k lambda by r I cap. As per the diagram also you will see that this and this will be cancelled and only d cos theta will prevail, and that's what we have proven also. Okay Janta, I hope this helps, and don't worry, session PDFs, the link is already updated in the description box, so do check out the description box as well. Okay, now this one Janta, let's speed up a bit. I have a class at 6:45 on Vedantu's platform, of course. It says that now it is established that protons and neutrons, which consist nuclei ka ordinary matter, are themselves built up of more elementary units called as quarks. So basically protons and neutrons are made up of quarks, is what question is telling you. Quarks are subatomic particles, subatomic particles. Okay, so a proton and neutron are made up of 3 quarks, and that too of 2 types. The up quark is denoted by U and has a charge 2.3 e, while down quark is called D and has charge this much. So how many such quarks will be required to make one proton and how many will require to make one neutron? Okay, lack of space, so I'll have to be careful. So first part, everyone, for proton. Okay, so total 3. So I say that number of up quarks say is n and number of down quarks will become 3 minus n, because total 3 quarks are required. So everyone, can I say that the total charge of proton is E, the total charge of proton is E, which is made up of n number of up quarks which have charge 2 by 3e plus 3 minus n number of down quarks which are minus e by 3 charges. Okay, e charge है proton का, n number of quarks है up quarks and 3 minus n number of down quarks हैं, दोनों के individual charges भी लिखती हैं. So e throughout gets cancelled. So here we have 1. This is 2n by 3 plus 1. This multiplies 1 by 3 here and in fact becomes minus 1. And this becomes minus plus n by 3. So this 1 comes here. You have 2n by 3 plus n by 3 equal to 2. This 1 goes to the other side. That means n is equal to 2. So this many number of up quarks. And then 3 minus n is 1. So these many number of down quarks is required for a proton. Okay, I hope you all understand this. 2 up quarks and 1 down quarks. So when you do the same thing here for neutrons, the charge is basically what becomes 0 for neutrons. And then when you simplify, you still get the same equation, that is 2n by 3 minus 1 plus n by 3. When you simplify, n comes out to be 1. That means up quarks and 3 minus n is 2. That many number of down quarks. So the first one is for protons. This is for neutrons. Okay, everyone? Moving on. Consider an arbitrarily electrostatic field configuration. A small test charge is placed at a null point where electric field is 0, we know that, of the configuration. Show that the equilibrium of the test charge is necessarily unstable. Second part says verify this result for a simple configuration of 2 charges of the same magnitude and sign placed at a certain distance apart. So we'll directly take the second thing only, which justifies the first part also. Okay, everyone? So we have, say, a positive Q charge placed here. Okay. And another positive Q charge placed here. If I place a test charge, okay, a test charge which is supposed to be a positive test charge, Q0. So you know that when it is here, it experiences same amount of force as it is at a distance r from both of them. So it experiences the same force. So if this is charge 1, this is charge 2, okay, so you have the amount of force experienced by this charge Q0 by both of them. This one is repelling it here, this one is repelling it there. So both of them are balancing as of now. So when you shift the charge to some other point, say you shift the charge somewhere here, Q0, now what happens? This charge is trying to repel it here, F1 dash, and this one is trying to repel it here, that is F2 dash, and you see that their resultant is not going to be 0. In fact, the F resultant is going to take the charge away, and that is why it is an unstable equilibrium for your test charge. So you will have to write this in words maybe, though it is from extra exercise, so you cannot, possibly put it in words. It will be very long explanation, but you will have to draw the diagram with all the explanation that you are giving. Okay, so I hope that makes it easy for you to understand that you place anywhere on this y-axis this charge Q0, it will remain on an unstable equilibrium line. Okay. Moving on to the second last one, and this one is after a long time, I can say that something more related to your competitive preparation has come up. It says that you make a negative charge enter like this, that too in an electric field, say that is E, and it has this plate length as L to which the electric field has been established. So charge particle which is negative will experience an electric field towards this side, which is QE amount of force. So because of that, your electron or charge particle will actually move towards the positive plate. So particle has minus Q charge, M is the mass, it is entering with a velocity Vx, the length of the plate is L, it is moving with a velocity Vx, entering horizontal velocity Vx. Question is asking us the amount of Y displacement, okay, or you can say the amount of width which is traveled along this side. Okay, show that the vertical deflection is how much? This much. You have to prove this. So first of all, everyone, the acceleration along y direction. Okay, along x direction and along y direction, if I say, so along x direction, the initial velocity is vx and initial vertical velocity is 0. Initial horizontal acceleration is 0 and initial vertical or overall vertical acceleration is qe by m. So when we talk about the y direction, we say that along y direction, the amount of displacement which is to be traveled is d, and this is given by 0 initial velocity plus half ay t square. Okay, so from here the time comes out to be 2y by ay in under root. I hope that you all remember the projectile motion where a plane used to drop a bomb. This is the similar situation in the opposite sense as far as diagram is concerned. Okay, now the horizontal displacement which is traveled is L, and that is equal to ux into t. So this L is equal to ux, which is given to you as vx, and this is 2h. I have written is y, but let's write it as d. D ही हमें पता लगाना है everyone. So 2hd by ax, sorry ay in under root. So we have to prove that this d is. So from here, I'll take some more steps to explain this. You have L square by Vx square equal to 2h d by this, which is QE by m. Okay, under root is gone. Rearrange and you get the answer. You have QE L square by 2hm or 2mh. What just happened? Okay, my bad, there is no h, it's d that we are writing. So 2d and this is 2dm, so this is 2mvx square, 2mvx square. My mind is thinking about that projectile motion, that's why h has come into picture. Okay, everyone, so what we did, basically we found out the amount of time which is taken to cover L distance or to cover this distance d. That comes out to be under root of 2d by ay, and that ay is the acceleration that we already know, and that is what we will put here eventually, QE by m, and simplify. Okay, in horizontal direction there is no acceleration, that's why velocity into time goes as the horizontal distance. Okay, now question says, last one, it says that in the previous question, if say d is given to you as 0.5 centimeter, so you have to find out how much will be L in that case. So you will say that L is basically Vx into t, while Vx is under root of 2d by ay. Okay, so Vx is 2 into 10 to the power 6 and under root of 2 into 0.5 centimeter, that means 5 millimeter. Okay, and this is it. Okay, so we'll be putting up the value of Q, E and M as well. So mass of the proton is mass of the electron, in fact, 9.1 into 10 to the power minus 31 kgs, and charge is 1.6 into 10 to the power minus 19, and the electric field is 9.1 into 10 to the power 2. So at least this 9.1 gets cancelled. Okay, and this 1.6 can come out of the square. So you have 2 into 10 to the power 6, everything in under root. If you see, this is 10 to the power minus 3, this is 10 to the power minus 34, 10 to the power minus 34, this comes up 10 to the power 20, so 10 to the power 14, 10 to the power 14 minus 2, 10 to the power minus 2, 10 to the power 14 it is, so 10 to the power 14, and below I have 1.6. Okay, a lot of decimals are still pending, so will not be 1 point, that is why this is. Okay, so everyone, this is 10, this is 10 to the power minus 34, this goes up, meets this 10 to the power 20, so the overall except these two becomes 10 to the power 34 minus 20, that means 10 to the power minus 14, minus 14 adds with this, so 10 to the power 16. So what you have is 10 to the power minus 16 divided by 1.6. Oh my god. So when you simplify this overall, it should come out to be 1.6 centimeter. Okay. I thought that you will have some power 10 to the power 16 or some even power with denominator becoming 16 so that I can take a perfect square of 16 out, but that's not going to happen here. And if that would happen, that will be 2 by 4, so 0.5 should be the value in the answer, but that's not the case, guys. Okay, so the answer is 1.6 centimeters. Do make sure that you are trying to solve the values also. Okay everyone, so I hope that ये सारे questions खुद से भी try किए हमने, and if you guys have tried the questions which you were not able to solve, I've given you the approach, I've given you kind of solution to everything. Only thing that I tried not to do myself a lot was the calculation. That is one thing that you need to anyway do, and as I told you, in your board examination they allow you to use the log table booklet, so get into the practice of using log tables at least for multiplication and division. It will be very helpful for you. I am telling you because I've done that in my board examination for the calculations which are very difficult, to make them easier. Okay, so that one tip that you can use, everybody. So everyone, now that you were waiting for the Telegram channel for Vedantu's NEET physics, so everybody, the link is also available in the description box, and I hope that you all enjoyed today's session. If you found the session helpful, do share it with your friends who are preparing for boards and are in science, have physics as their subject. And if you are new to the channel, do subscribe. It's going to help it grow, very frankly. Okay, Chinta? Superb. So saved. And let me tell you one very important thing. As you are watching this video, you will go on the video, and if you click on the description box, you will find the Telegram channel here itself. I'm the only subscriber as of now there, so do join. And these are the session PDFs. So when you go there, everybody, you will find, after clicking here, the NCERT solutions of the previous session are already uploaded, and similarly this one will also get uploaded, which we have just now finished. Okay, so all the solutions in the handwriting with most of you like, you will find it here, the detailed solutions. Okay everyone, so I hope everybody is clear what to do. Description box check out zarur karna, and I will see you guys in the next week. And as many of you guys are expecting, let me come back with some series for all of you guys for NEET preparation. That reminds me, hold on, sorry, I'm going to say goodbye. If you go on community, I have 2 questions that I have posted. I need your answers on. First thing, what you want me to do for NEET. So now that mega marathon is what has been asked by many students, so I think I'm getting inclined towards this, and this one is anyway running. Okay, NCERT series. So later on, maybe one shots and chapter wise PYQs will do. And second thing that I want your answers on, see, this is my my problem is, it's the dilemma. Which language do I choose? मैं कौन सी language में पढ़ाऊँ? I'll start speaking in English and we'll have like subtitles here in Hindi. Ulta. Of course. Or I'll start speaking Hindi, pure Hindi, and then English subtitles. That's very difficult. Okay. So I hope that everybody is asking their friends to come and vote here. And of course want them to come and study also on the channel. Cool. Fine, so enjoy your weekend everyone. I'll see you all hopefully in next 2 days. I'm going to come up with a plan, and stay tuned here. Okay, and I will share the details before I come live. Till then, take care. Bye bye. Good night and a happy weekend to all of you. Take care.